So in derivative we have currently will be using 2-point method. Okay, 2-point method. So we would require 2 points to evaluate the derivative. For example, we have 2 points x0 and x1. These are 2 points which would help us to approximate the derivative x0 and x1. So how these 2 points will be used? So for example, if we would like to approximate the derivative at any x0, it should be equal to f of x0 plus h minus f of x0 divided by h. Okay, so where h is basically difference between the upper and minus of the interval, whatever the interval for the derivative is given. So h is b minus a. Okay, so upper minus lower.
Values of the interval?
Yeah, interval or the the successive x we have been given. Okay, that is the interval of the successive x. So for example, if we have been given the x in term of, let's say, 1, 2, 3, so these are the x values. So here if you want to determine the x, so x will be the upper minus lower, which is h, upper minus lower, which is also h, so which is 1. You see, you could see that the gap is the same for each of the upper minus the lower interval. So 2 minus 1 is 1, 3 minus 2 is 1, so that is called the h. Okay, so that h will be used here, f of x0. So x0 is the point for which you want to approximate the derivative. Okay, and h is the, so only you have 2 things, rather you have 3 things. So you must have your function, must be evaluated at x0, and your function must be evaluated at x0 plus h, so that you will use all those values to put into the formula and to get the derivative. Okay, so you must have f of x0 and f of x0 plus h. So if you have all these 3 things, it means that you will be ready to calculate the derivative. Okay, so now we'll be telling you there are 2 formulas that is relating with this type of approximation. One is the forward and another one is the backward. So forward when h is greater than 0 and backward when h is less than 0. Okay, it's depending upon your h. When h is greater than 0, you will be considering forward. When h is less than 0, then you have to take the backward formula, and the formula is the same. The derivative at x0 plus h minus f of x0 divided by h. So for forward difference, the formula will remain the same. For backward difference, the h will replaced by minus. So minus h and minus here as well in the denominator, minus h. Okay, so for backward difference, so h will be replaced by minus h. So for backward difference, h will be replaced by minus h. Okay, so that is the whole story of using this formula. Now we'll try to pick one of the example to solve so that you will understand it more clearly. Sorry. I have to turn on the control. Now I'm calculating f dash at 1.8, and the formula will be considering this form, and by putting the values of 1.8, so 1.8 is corresponding to 10.889 divided by same h, f dash of 1.8. 18.14. That's it. Now, for example, I would like to calculate f dash at 2.2. I would like to calculate h f, the function at, I would like to calculate the derivative at 2.2. So then what will be the formula? F of 2.2 plus h 2.2 divided by 0.1. So here is some critical point to be considered here. Okay, some critical point to be considered. For example, f of, we are getting, for the first function we are getting f of 2.3, and we could not find f of 2.3 into the table. So what is to be done? So here in this case we will apply backward method. Okay, so in backward, what we have to do? We have to reverse the sign of h. We have to reverse the sign of h. Wherever you find the h, just reverse the sign of it. And backward, what we have to do? We have to reverse the sign of h. So the sign is currently minus. So in backward, I am reversing the sign. It is minus here, and it should also be minus here. Okay. So now we have to put the we have to calculate f of 2.1 minus f of 2.2 divided by minus 0.1. So now we have 17 point, so function corresponding to 2.1 is 17.148 minus function corresponding to 2.2 is 19.855. So divided by minus 0.1. So the final answer is 27.15. So that is the answer of f of 2.2, and we have obtained this answer through the backward method. 27.07. Okay, that's okay. 27 is there, is no problem. Decimals is not that important in this case. Okay, so that is the approximations by using the 2-point formula. Currently we are using 2-point formula. Later on, now we'll be moving to the 3-point formula. I mean, how 3-point formula will be used to approximate the derivative. So these are 3 formula which is very important. So the first the formula that will generate the next point. Okay, the first formula that will help us to generate the next point, and the backward formula will be generating the back point. Okay, and the midpoint formula will be generating the middle point. The point is that for the first formula we need 1 point, the starting point, and then after we need other points. For example, in the same question, let me tell you through the table. It will be, help you to understand the logic behind the formula. The same table. For example, this is the table we have. So if you could see that, if you want to generate f dash at 1.8, okay, so it means that you would require, if you are using forward difference formula, you would require f of x naught plus h and f of x naught plus 2h. So it means that you would require 1.9 and 2, which is there already. Okay, it's there already. So for example, if you want to apply 3-point backward formula to approximate f dash of 1.8, is it possible to calculate f dash, the derivative, at 1.8 by using the backward? Is it possible? Yeah. If you want to calculate the derivative at 1.8 by using the backward formula, is it possible? Is it possible? Not possible, because you don't have x naught minus 2h. You don't have any previous value before. You don't have any before value before 1.8, and you don't have any value x naught minus h. So it means that if you wanted to apply the backward formula for f of 1.8, which is the starting number, so you cannot apply the backward. So backward will be applied here at this end. If you want to approximate f dash of 2.2, are you getting the point? If you want to approximate f dash at 2.2, it means that you would require 2.1 and 2. These two values would be required because it's a backward. Okay, so you can use 2.1 and 2. So for example, if we're talking about the midpoint formula, so midpoint formula cannot be applied at 1.8 and cannot be applied at 2.2. Why? Excuse me. If yeah. So for example, this is the midpoint formula. This is the midpoint formula, and I want to approximate f dash at 2.2. At 2.2. So it means that 2 into 0.1 f dash mean 2.2 plus 0.1 minus f of 2.2 minus 0.1. So 0.2 f of 2.3 minus f of 2.1. So you can see that this term 2.3 is not existed in this table. It means that midpoint formula cannot be applied to the edges. Edges means starting value, which is 1.8. We cannot apply midpoint formula. Are you getting my point? What I'm trying to say? Because there are three formulas. Okay, so midpoint formula cannot be applied in the beginning and nor at the end. Midpoint. So midpoint formula can be applied any value starting after the first value and any value before the first. For example, the midpoint formula is very good to apply at 1.9, at 2, at 2.1. So as soon as you are reaching to the last value, so no, don't apply the midpoint formula. Okay, so for last point 2.2 you have to apply the backward formula. For the last point, which is 2.2, you have to apply the backward, and for the first point you have to apply the forward. Okay, even though backward and forward could also be applied later on, but we have to be careful. For the beginning value we cannot apply. For 1.8 we cannot apply backward formula and midpoint formula, and similarly for 2.2 we cannot apply midpoint formula and forward formula. Forward formula cannot also be applied at 2.2 because forwardly we don't have any number which is 2.3 we are needed. So here is the list of 3 important formulas for 3 point: forward, backward and midpoint. Clear? So currently we have covered 2 important part of the for its numerical differentiation. One is having 2-point formula which is backward and forward, and another one 3-point formula which is having backward, forward and midpoint. So now I'm gonna give you one of the question so that you could try all these 5 formulas. Try to generate at least one of the number by using each of the formula. Okay, so now I'll try to because now I have started the recording. So the first question, you need to fill out the third column, which is these 3 values. For the first value, f of x naught is 0.5. For the second value, f of x naught is 0.6, and for the third value, f of x naught is 0.7. So accordingly, for the first 2 terms we will apply the forward, and for the last at 0.6 we will apply the backward formula. So the forward is written as f of 0.7 minus 0 and f of 0.7 divided by minus 0.1. Okay, that is the backward one. So you will calculate it, you will get the answer. So 0.2 and f of 1.3 is 13.46 minus 9.025. So after solving you will get the derivative at 1.2. So let me little bit revise. At 1.1 we will apply the forward difference formula. At 1.2 midpoint is very appropriate. At 1.3 midpoint is appropriate, and for the last 1.4 we will apply the backward formula. Okay, backward formula will be applied here, which is equal to 1 over 2h. 1 over 2h. What is the formula? F of 1.4 minus 2h. 1.4 minus 2h mean 0.2 minus 4 1.4 minus h plus 3f of 1.4. So you just need to put the values to get your answer. f of 1.2 is 11.02, f of 1.5 is 1.3 is 13.46, and 3 into plus 3, f of 1.4 is 16.44. Okay, so that's how we compute the 1.4 by applying the backward difference formula.
We should memorize formulas.
Yes.
How is this step? Learning.
Hmm?
Bring it for us.
I'll give you in the final.
Also the test.
Final test.
Please.
Okay, I'll try to give you in the test as well. Okay. Okay. Okay, that's it. I think it's easy.